you ex-KCD's take, Randall Monroe's take on Python. It's so easy, right? I learned it last night. All right, before we get started, so as usual, as you know, for these computational bioinformatics lectures, go ahead to Blackboard, download the notebook and the data file for today. I have one announcement about the homework. We have extended the due date till Thursday. I know it's been it was a lot for some of you to complete, so we'll give you some extra time to finish it. Give me some time to finish the next homework for this. All right. So go ahead and as you probably have already done, possibly open up a fresh notebook. Today, instead of some slides, we're gonna start out working straight up from a blank notebook. So we've given you a lot of information over the past 5 lectures. Our philosophy, especially in the computational part of this course, has been to do something first to get a feel for how it works, and then sort of come back later and figure out a little more in detail what the syntax is, what the logic is behind it. So I thought I'd start today out by just stepping back a little bit and reviewing what we've learned about Python syntax, and hopefully we can consolidate our knowledge and you leave realizing how much you've learned over such a short period of time. Really, the things that you've learned fall under just a few key programming concepts that will really take you a long way. You can really do a lot with just a few of the core ideas that we focused on. And so the first core idea that we're going to review are these basic objects and data types in Python. So we're just going to go through and we're going to explore. We're going to explore some data types. If there's something you want to try, go ahead and try it and follow along with me here. And what I want you to get from this is not just a review of the concepts we've looked at in perhaps more of a simple context, but encourage you to try things as you go along, because that's how you really learn a new programming language. All right, so let's start out with one of the easiest basic data types that we know about, numbers, right? So we've looked at, is this legible? Should I zoom in a little more? Everybody, if you can't really see it, let me know. All right.
A little bigger.
A little bigger?
Yeah.
The comments are especially hard to read because of the green there. Good. All right, so numbers. Numbers is something we often use, and as you've noticed, there are a few different types of variables with numbers. So we can have something like this: assign a to 10. Here we have another variable. It's like this, and I'm going to put something else under the category of numbers here, something that might seem not necessarily a number-related thing, but okay, we've created 3 variables here. Let's see what Python tells us about these variables that we've stored. So we're going to use this a lot today. We're going to use the type function, and it'll tell us the type of number, type of data object, essentially, that's being stored in these variables, right? We've assigned several different objects to a variable. So here we'll do type B and type C. Hit Shift Enter, and you can see that these 3 variables come here in 3 different flavors, 3 different types of numbers. The variable A holds an integer. Variable B holds a number with a decimal. It's called a floating point number in programmese. And the third type is a Boolean type. It can be true or false, and sort of serves as we'll see a little later, it takes on the value of 0 or 1. So you can treat Boolean types in a way as numbers. I want you to notice here, when you type the word true, and notice it's not in quotes at all here, you get this bold green statement here that tells you this is essentially a word that is recognized by Python as a special special word. It's not like if you try to do, try something else like this, cat, you know, or DNA without quotes. Notice it's not a specially recognized word there. All right, so we have a few different types of numbers. So that's one set of data types. Let's look at another one: strings, character types. These are the data types that are within parentheses. So we can do deoxyribonucleic acid. See, I can't type very well here. So that's all characters. There's a space in there. There's some letters. But you know, they don't have to just be letters. So let's try E here. We can put in a gene name. It's got some numbers in it. Whoops. Sign it. In fact, it doesn't need letters at all. We'll try this here, E2. I added extra variables in this thing, so some have numbers on them and some are just letter names. Let's try E2. And let's just try 10. But this time we're putting 10 in quotation marks. All right? Now let's, again, look at our types. So D. Can you, I don't know, does this work? I haven't tried this. Probably not. Anybody know? Don't think so? Yeah, probably, right? Yeah, you got to do the type statement. I want to encourage you to explore. You know, you look at something and think, well, does it work this way? You can always read the documentation, or you can just try it, right? E, and then type E2. All right, these are all, these variables are holding data of the type string, str, right? So the difference, as you can see, between 10 here and 10 up there is it's in parentheses. And the IPython notebook gives you this helpful syntax coloring. Notice these guys are in green. This is a bold green, showing you that the word is recognized here. These guys are in red, and they're in quotes. You could also use single quotes. Basically gives you the same result there. All right, so we got strings. Let's move on to some slightly more complex data types. Data types with multiple values. This is where it gets interesting here. So you could, let's try this. Let's imagine a series of numbers here. We can do this one, 3, 5, 7. Just pick some odd numbers. There, without quotes, without brackets, without anything. Let's try the same thing, but let's put it in square brackets. So we've seen lists. Lists go in square brackets, right? 3, 5, 7. You can line these all up. We could use curly braces, right? Now each of these will give you something different here. So let's again check the type of these different variables. F, G.
Should I each have the same numbers?
Oh, sorry. Yeah. Trying to make a point here that put the same numbers, you change the braces, and you'll get something different. Thanks. Yeah. Type H. And let's take a look at that. We have 3 different data or object types here. The first one is called a tuple. You know, you can think of that as like a triple of numbers. Often we get things that come as pairs of numbers, like an XY coordinate. The numbers come together as a group. Here we have a list. When you've seen this often before in your homeworks and in class when you put it in the brackets. And then we have a class called set. All right, let's explore the differences between these 3 ways of grouping the numbers 3, 5, and 7 here. We gotta come right back. Let's try this. So let's do F. We'll try our indexing notation. So all of these are they all indexable? Let's look at that, right? So F, we entered F0, it gives you the first value, right? Let's try this with, here, we'll use another cell as we go down. Let's try G. Again, now we're using square brackets in a different sense here. It's to grab a certain position within this within the data object here. It says G0 also gives you 3. Now what happens if we do H like this? We get an error here, right? So set object does not support indexing. Why is that? Well, so the tuple type here, F and G, both store our numbers in a particular order. These are ordered data types. So 3 is in slot 1, 5 is in slot 2, slot 0 actually, we start counting from 0. But a set is actually an unordered data type. And I believe you encountered sets briefly in your homework. So sets serve a different purpose. If you have an unordered data type, but you want to find things by their labels. So let's try, instead of indexing, wait, does this work? I can't even remember. No. How do we do, I have to put this in quotes. See, we're going to explore here. I can't even remember how to get these.
You can test for membership 5 in H.
5 in H, okay. It had some indexing in there. Yeah, so we can test for membership, right? So that's a fast. But if you wanted to, right. Five. I guess I'm thinking of dictionaries here. 5 in H. Probably without the quotes, right? Because this is a number here. There we go. All right. So.
And that's probably a useful distinction. What's the difference between 5 in quotes being in H and 5 not in quotes being in H? Why is one true and the other false?
All right, anybody got it? An answer?
Quotes is a string.
Right, is a string there. So, and this one is a number. So one of the key points that I want you to take away from these complex data points is something I mentioned before in an earlier lecture. Complex data structures are made up more or less of simple data types, data objects. So let's try. So if you went back here and if you put these like this, made them string types, so we enter this, and then we do this. So now it's false, and now it's true. Right? There we go. All right, so the idea I want you to take out of this is that sets are unordered. We can't index them the way we can index the other two. So there's something else we could index. Let's go back to D. Let's try D like that. You can index strings. So this is also clearly an ordered type, right? These letters come in a particular order, so you can grab items from a string that way. All right, let's try another data type that you have briefly encountered. These are dictionaries. So let's enter this here and see if we can figure out what's going on with this based on the bracket type. So here's a dictionary, right? It's curly braces. So does that suggest this is maybe an unordered data type, right? And so a dictionary is made up essentially of labels, sometimes in some languages called keys. I don't know if that's what they call it in Python. Labels. So you have a label, and then you have your data values. So we're going to go back to that Monty Hall problem you remember from last time. We're going to build things with door number 1 and goats and cars here. So let's take a look. So we have a goat. You could build a dictionary of of Monty Hall's options. So we use a colon to make these. Whoops, sorry. Door 2, goat, and then we could have door 3, car. And you see how these come in pairs, right? Your pair is individual pairs are separated by a comma. The parts of a pair, there's a label, and then there's the data value, are separated by the colon there, okay? So if we do type I like this, see it's a dictionary. Now, this is where I got mixed up. This is what I was trying to do with the sets, but you can grab things by their label. Whoops, there. All right, so these are a dictionary is something where you can grab by its label. If you tried to grab it by indexing, you get an error. All right, you definitely grab it by its. Any questions so far? Does this make sense? It's pretty straightforward example. All right, so this is a really convenient data set if you want to grab things by, if you want to quickly grab things by a label. You know, you could store, you could imagine, you could store more complex data here actually. You can store addresses and you look them up by name or things like that. You can store data about genes if you wanted to look things up by their gene name. If you take the genomics class next semester, you'll get a lot of practice using these dictionaries. All right, so those are some of the main basic data points in data objects in Python, the ones that you'll use most often. There are some other ones we've become familiar with that are specific to pandas. So let's import pandas here. Oops, I left out the pandas, sorry. So we'll bring in pandas. My computer's running slow today. All right, now we're going to try something that's kind of like a dictionary, kind of like a list, but not quite. A series. So these have cropped up before as we've worked on these, as we've worked with data-oriented pandas. So let's try this. So here's so imagine this dictionary. Here's the setup for one round of Monty Hall there. So let's group that one round put that one round as a game here. So we'll call it game one, and we're going to make it a series object. So let's see, we need the assignment variable, pandas series will let you create a series object. Now, I'm going to show you, there are different ways we can make a series. But let's do it this way using some lists. So first we'll give it some data, goat, and car, okay? So there's our data for the series. Now we want to put labels on our data. So just like a dictionary, a series also gives you labels on your data. So we'll have index, and we're going to give it another list. So remember, these square brackets are lists. We're making more complex data types out of simpler ones. So door 1, door 2, door 3. There we go. And you hit Shift Enter, and you can ask, what's the type of game 1? It's a series. Let's see what game 1 gives you if you just look at the variable. There you go. See, it gives you a little table. So game 1 is interesting because, well, let's take a look at it here with the indexing. You can index it by position, but you can also game 1. Let's try this, right? Door 1. You can index it by label. So what this tells you here is that game 1 is definitely ordered. A series object is ordered. Things are in the first position, they're in the second position, and the third position here. But you can also grab them by their labels. So it's essentially kind of like I said, kind of like a dictionary, kind of like a list. It's ordered, but you can grab things by their labels. And in fact, it's so much like a dictionary that you could actually make your series object from a dictionary. So let's try this. Series. Now remember, I'm going to scroll up here. We created this dictionary I. Okay? So you could actually just type I, and we'll look at game 1 again. Oops. And you get the same thing. So there are different ways you could put this information into a series, and then you call the function, the method for creating a series, and you can create this object. All right. So what happens if we forget to put the labels in the series? What happens if we don't really care about the labels? Let's try no doors. We're not going to give it any door numbers this time. PD series. So again, we'll do our goat car. All right. Well, that worked. You didn't need to give it some labels. So, but what happened? The series method created its own labels. Basically gave it numbers 0, 1, 2, 3. Well, how does indexing work then in this case? So obviously you can do this, but you could also do, let's try this. Does this work? No, not in this case. Okay, so these aren't labels the same way. So explore. All right. Let's make a few games here. So in this case, save ourselves some typing. I'm going to copy and paste this. Let's try a few games. We'll try game 1. Let's do 3 more games. So let's do game 2. We're going to make a data frame here. Game 4. And we can rearrange the outcome if we want. Goat. Put the car up here. Goat. Sure. And we'll keep that one the way it is. All right. Hit shift enter. So we have 3 more series. Now, again, go back to this idea. More complex data types are made from simple data types. So let's make a data frame from all these series. All right, so here we will make a data frame. So we can essentially, just like we made a series, we made it out of a dictionary or out of a list, we can assign a variable, we can call it games. And there's a pandas data frame series, data frame method. And let's do it this way. So we're going to put on some, we're going to create it essentially out of a dictionary here. So I've got some braces. We're going to put a dictionary. We're going to assign a label to each game here. We'll call the first one game 1, and then we'll assign it the series data type game 2. Separated by a comma. 2, game 2. Oops. Let's do that. 3. 3. There. All right. So do you see what we have here as we're typing in this row? This is essentially a dictionary. Inside of the parentheses for this method that we're going to call, we have a dictionary. We have our curly braces. We have a label, or a key, essentially a name, and then we have some data. And in this case, the data is a series. So when we first made our dictionary, the first dictionary I up here, the data was just a string. In this case, the data is something else. It's a series. You can still make a dictionary out of it. And recall, a dictionary is unordered, but if we wanted to happen to put this in an ordered form, a pandas data frame object will create an ordered table for us. So we have door number 1, 2, 3, and then we have our games. But oh, interesting, right? So the labels don't come quite in the order you expect. But remember, I told you a dictionary is an unordered object. So sometimes you get this, if you're creating a data frame out of this unordered dictionary, you occasionally get this weirdness. So how do we avoid it? Well, let's try this this way. We're going to reassign games. you can use a slightly different method. And how do I know about this? I Googled it, right? I saw things came in the wrong order. I went and looked it up, and sure enough, somebody wrote a method for putting your dictionary together, or putting your data frame together in an order. So the idea here is to actually use an ordered data type. So let's type this out, and then we'll look at the syntax here. So I have a bracket. Just type this out, and we can talk about it. And we're going to put our pairs, we're going to, instead of separating them by colons, we're going to separate them by a comma. Bracket, this here. All right. I know you can't see the whole thing in one row here, but we'll start from here. All right. Enter. All right. So who wants to tell me what's going on here? Think about your simple data types now. We have we're calling the data frame method from items, and so what's inside of that? What's inside of the first set of parentheses? What do we put there? Everybody, what kind of data object? We have these square brackets. This case, it's a list. We're not indexing. So if you want an index, you're going to have your variable name followed by that right next to it. In this case, we actually have something. We have what is essentially a function, some parentheses. And then on that side, inside that function, we put something in square brackets. So it's a list, right? So we've created a list here. Now what's inside of this list? They're essentially tuples here, right? But let's try this. Let's see if that's what we get, right? I want to encourage you to explore, so we're going to do it this way. Let's just call this variable, I don't know, G3. I can't remember if I used G before or not. Let's see if that actually gives you a tuple, right? Because remember, game 3, whoops, there we go. Interesting, right? The tuple is, right, this is actually, the game 1 is a series here. So we've managed to put a series inside of the tuple. So what if we did G3, and we can index it that way, take a look at it, and there's your whole series. All right, I don't want to get too far off track, but the point is that now we have a more complex data type made out of simpler data types. So when you see, I'm going to get rid of these just to not clutter it up. So when you see a statement like this, break it down. Think about the brackets, think about the parentheses, think about what's going on in here. All right, so we're going to make a data frame. In that data frame is a list of tuples. And the tuples contain a string followed by a series. So does that make sense? Any questions at this point? All right, and now we have games. Again, gives us our data frame, but oh, look, now our columns are in order. So that was one. There may be other ways to put your columns in the right order in Pandas that I'm not aware of. This is the way that I found to do it. So there's always a solution. What's that? Yeah, I don't know if dictionaries. I guess yeah, this does look alphabetical. I don't know if in Python do any of you know? In Python, our dictionary is actually. Well, this is the data frame method. So the way a dictionary is ordered internally in the internals of Python is not necessarily alphabetical. It's behind the scenes essentially. You shouldn't worry about how it's ordered.
Yeah, they're in order. They're in order because the logic behind using a dictionary is that you're going to use the keys, so you don't have to use anything else.
Yeah.
And it's easier for them to save it without an order.
And so the way it's stored as a variable is not necessarily, it's not alphabetically ordered, it's not, those are the Python internals that you don't want to worry about, just keep in mind it's unordered. So sometimes, in this case, it seems to have come out in alphabetical order. I don't know, that could be something of the result of the data frame method. I don't know, I wouldn't worry too much about how the orders come out, but you can find, though, there is a method that will put it in the right order for you. All right, so all right, let's just keep going. Let's do what we've done here. Games is a data frame. Now, what if we just pick one column out of games here? So now these square brackets are indexing, right? We're going to call the column 1. Games, sorry. I am terrible typer, right? And that's a series, right? So again, the point, you have a more complex data object made out of simple data objects. All right. All right, we're almost done with this little exercise here, but let's do a little indexing here. So it can certainly get confusing. So one way to index, right, is just using this, using the square brackets. Here we got one. There are some different indexing methods, so let me just note them up here. So you may have seen these. We've touched on some of these in class and in the homework. There are various ways of indexing, and when you look at this list of various things, it can seem confusing. So let's explore. So when you use this, all right, let's see, does this work, right? So this expects actually two values. So let's try door 1. That works, right? We grabbed our cell. Door 1, game 1, the entry is a goat. All right, let's try it with this function. So if you go to the pandas documentation, it gives you these list of possible indexing functions. Does that work? No. The I actually stands for indexing. So what it expects is numbers. So you could give it something like this. And that works, right? But what if you did this without that indexing method? It doesn't work, right? I'm not trying to confuse you here, but I want you to get the idea that there are different ways of indexing this. Let's try this with I at. That's another indexing method. It's a particularly fast way of grabbing single cells. But if we remove the I and we try it this way, it gives you an error, but we could use our labels, and then it works. Okay. Now, what if you want to grab by row number and but use the label for the column like this? So what if we wanted row number 1? Well, in that case, you can use the IX method. It lets you do a hybrid. Okay. So I encourage you to just play around with these. I know we've done a lot of indexing in our activities. They've been a little, it can get confusing when you're trying to grab a column, when you're trying to grab a row, when you're trying to grab a set of rows. What if we wanted to grab first 2 rows? You could actually use it's called a slice, right? And it gives you the 2 rows like that. So I encourage you to experiment with this. Let's see. Two more points of review. So let's call it quits here with the data objects. Any questions on this? Any particular aspect you want me to go over? So these are just some of you've learned some simple data types, you've learned some complex data types. There's some powerful stuff you can do with those. All right. So let's move on to one of the other key programming concepts that you've learned about. For loops, right? Here we go. So we're just going to do this in a simple way here. You've basically encountered two types of for loops. They're essentially the same thing, but we're using a for loop in a different way. The first way is to iterate over items in a data structure that holds more complex items. Let's see. So for item, this could be, right, item is it doesn't matter for item. You've seen that. You could call it Z, you could call it whatever you want. In I, so there. I, remember, was our dictionary that we created. Print. What did I do? Print. Z. Right. So it iterates. It grabs an object from our dictionary. Yeah, I shouldn't have used a dictionary for that case because this is kind of. That's right. It grabs an object in a list of data here. You've seen another way of using for loops. This is where you iterate over an index, which can be useful when you need to use that index to grab. When you want more than just an item, you want other things possibly. So do index. It doesn't have to be index. That could be, y, whatever you want. In, and then we use the range function. This is very common Python syntax. I remember we created, here, let's zoom all the way up here and look at G. G is a list here, right? Probably should have done G up here. There we go. Let's do this with G. Right, so there's our list that way. But if we want to use an index to access G, we could go print G, and then we give it Y. That. In fact, let's print Y and then G just to show you, right? You get an index, 0, 1, 2, 3. That index then gets plugged into some more complex data structure, and how do you get it? So you have for loops over an index, or for loops that grab items from a list, usually, or some other type of structure. Okay. Let's see how much time we have. So let's stop there with the review, just to make sure we have time for the activities. So we'll do one more item, right? So you have if statements, you have conditional statements, right? If we can take our dictionary, G, remember G is a list of numbers, so if some number, or you don't even need to do this, if 6 is smaller than 7, right, prints true. Now this is true not in the Boolean sense, this is a string here, right? Conditional statements. They're pretty straightforward. And you can add alternatives. Right? Else, print false. You can change the number and get the different outcome. Right. So those are pretty. The logic behind those is pretty simple, right? But remember, you can plug. The theme here is that you can plug more complex data types. You can create these statements, and from these simple ideas, basic data types, for loops, and conditional statements, you can create a lot of. You can do some powerful things. So that's our brief review of the Python syntax. Any subject we touched on that anybody has questions about, you'd like to get into a little more? Yeah.
Could you use sort in the for case when it gave you the wrong order and print it out in the right order?
Nah, too much about computer programming to be asking questions in this class.
Well, sort is. So, yeah, I know you can use that in Perl. You can presume you can use that in Python as well, too, right? So if you wanted to print a dictionary, let's try this. Sort. Is that going to work?
I got sort.
Is it I.sort? I know how to do this in Perl, but
Print I dot sort, you might be able to, I'm not sure.
yeah.
Or you might say like
Sorted.
You might be able to print Z dot sort or something.
Sorted?
I.
There we go. All right. Yeah, so there are ways to order your dictionaries. And this is actually a common thing, and certainly when I write scripts, Perl sort of thing comes up a lot. Sort command is very handy.
So just to clarify, do you have a list, make a list with sort of 3 elements out of place?
3 elements out of place?
Like
Okay.
517 or something.
Yeah, here we go. 517.
Okay. Now we can print out J.
Yeah.
All right, now if you do J.sort, that's going to sort J in place. So it's
Is
not
it
going
like
to give
this?
anything back. You run it,
Yep.
and then if you print J, it'll show up as in that order.
Nice.
But if you do sorted parentheses J, that'll give you back a new list. You haven't messed with your old list. It'll give you back a new thing that's in order. Because sometimes you don't want to scramble the old order.
Mm-hmm.
You know, we've done a lot of things where you have 2 lists that sort of talk, you know, are in the same order for a good reason. And so if you sort one of them, they're going to be completely scrambled up.
So, it's good tool to keep in mind.
Can you move that up?
Yeah. What do you want to look at? The sorted? Yeah.
Yeah.
Right, so let's, so we ran this, and then, you know, now we can print I. Well, that's not going to show you. That's going to show you how it's a dictionary, so it's better to do it with a list, like the example that we just did. All right, so we're going to put some of these activities into play, some of these ideas into play now in our in-class sort of independent breakout activity here. All right, I will save this. I'll put it up like before up on Blackboard. Play around with it, explore. That's the way to learn these concepts. Okay. So let me briefly introduce the main. It's not the main theme of the day because we've done this now. The theme for the second half of our class is going to be functions. All right. So you've been playing around with functions before in some of your previous homeworks and in class. Let's back down again before I go on the board. So you've played around with functions that basically take the format like this, right? You've seen this before. You want to define a function, you give it a name. I'm just going to do a really simple example and then we'll move on to our activity. The function gets a name, it can take parameters. You know, you call it parameters. So number 1, number 2. And inside the function does something, right? So it multiply number 1 times number 2. Right? It'll do some sort of action, and then the function's taking an input, right? It's taking an input, these 2 numbers. Usually, you want it to return an output, so we'll return v. So we've defined a function. So what happens if we do, so we can assign this to a variable, result. Now we have this you can give it 2 numbers, see what the result is. Right, it multiplies the 2 numbers. Right, did something inside. I want to show you when you're writing functions, you can also assign default values like this. So what happens if we do that? We give it a default value. So if I give it 2 arguments, let's do this. So it'll still give you the same result. If I only give it 1, it's going to plug the default value in for number 5. And still carry on with this. Now, if I didn't have this, if I didn't give it a default value, and I gave it the wrong number of arguments, oops, I could re-execute this cell here, and give me an error. So, this is just sort of a quick review of functions as we lead into this activity of what goes in, right? You have a definition, you give it a name, it takes a set of arguments, it does something on the inside, it returns an output, and you can assign that output to a variable. Some functions require a certain number of parameters, others will have default values. You can give it a default value in case somebody, in that case it doesn't require it.
Is return a specific function to functions, or like what's the could you put print instead of return?
Could you put, I'm sorry, what?
Instead of return, like what's the difference in using return and print within the function?
Oh, print, okay. So, well, let's try this. Let's try print. It's going to print V, okay? We'll re-execute that. Now look here, so we're trying to assign